I'm Tim Hamp, and in this video I will discuss how to set size standards for analysis of your spectra in PeakStudio. If you haven't watched the Getting Started tutorial video yet, you may wish to do so before viewing this one. Fragment analysis samples that are run on Applied Biosystems genetic analyzers can only be sized if a size standard such as Applied Biosystems GeneScan 1200 Liz is included along with the sample when run on the instrument, so it's important to make sure that any sample files you import to PeakStudio were created from runs with size standards. It is also important to make sure that the peak calling algorithm has been able to correctly identify the peaks in the size standard once they are loaded into an analysis software such as PeakStudio. Before I begin sizing, I'm going to right-click down here in the table view, go to Show Columns, and select QC number. You'll notice that this new column only says NA, but in a moment values will be assigned. In order to do this, I need to associate a series of size standards with the spectra. This is done by clicking on Edit, then Standards. The format of the size standards definition file is important. The file must be saved as a .txt or text file, and each size must be separated from the next by a line. Here is an example of the file used for the GeneScan Liz 1200 size standard. I will click on the Import Standards button, then select the appropriate size standards definition file. I want to apply this to all spectra. Now you can see that the QC number column has values. QC numbers are calculated through a linear interpolation process in which the absolute value of the difference between a predicted location and the observed location of each peak is divided by the total number of peaks observed in that file. Most often, in files where the run has gone smoothly and the peak calling algorithm has successfully called size standard peaks, values are somewhere around 0.18 to 0.30. In continuing to assess the accuracy of size standard calling, I will right-click, go to Spectra, then unselect Blue. Since blue is my data channel color, I don't need to look at that right now. I just want to see whether the peak caller could identify all of the size standards first. Now I can click at the top of the QC number column to sort that column. You can see that there is a value which is much higher than my normal range. If I look at the number of peaks column, I also see that the peak caller has only identified 67 out of 68 potential peaks. I am going to use Show Graph to display the electropherogram or spectra for that FSA file. I would like to view this in length of nucleotides rather than in raw data, so I will click on Axis, then base pair. This converts the display to base pair space. I would also like to display the axis, and that is done by going to Axis, then Display. Right away I can identify the rejected peak as it has been colored pink. I want to see the sizes and numbers that have been assigned to peaks, so I'm going to click on View, then Show Peak Numbers. I can zoom in using the scroll wheel on my mouse. By mousing over this peak, I can see why the algorithm rejected the peak. The peak was rejected due to an abrupt jump. In other words, there is an unusually steep incline in the data, and the algorithm has tagged this peak as one which should be confirmed by hand. Often a peak with this characteristic might be an artifact, but in this case it is just a very steep size standard peak. Now I can double-click on the peak, right-click, and select Toggle Peak. You'll notice in the table that the number of peaks went from 67 to 68, and the QC number is now in the same range as the rest of the values. The rest of the samples look fine, although when working with new data, you may wish to verify that peak calls are correct in all files. PeakStudio also enables users to make a more global change to spectra which exhibit abrupt jumps or other phenomena that makes peak calling difficult for the program. by highlighting one or many spectra in the table view, then going to Edit, then Parameter Set. I can uncheck the Apply Abrupt Jump option. Using the radio buttons, I can determine whether I want to apply this to all, or data and standards, or just data, or just standards. If I selected multiple spectra in the table view, I could decide to apply this to all selected standards. In this case, I will apply to this spectra only. Again, the QC number and the number of peaks are correct. Next, I will add my blue data channel back in by right-clicking, going to Spectra, and selecting blue. I will also turn off the orange data channel since I am confident that it has been called correctly, and I no longer need to analyze that part of the files. Keep in mind at any time you can restore those spectra by selecting the orange color again. At this time, I am free to view my data.